Hello and welcome back to some more Bitburners. So in the last video I showed you guys how to make your corporation much more stable and also left off grinding out the research points. So I left this game running for an entire week and discovered that I still didn't have enough research points to actually progress through what I was intending to do. And so I discovered an exploit that allows you to bypass all the grinding and then the waiting aspects of that. So I created a script called DevTools, and what this script does is that it's going to allow you to access the DevTools UI that the devs use or the open source community use to actually debug some of the aspects of this game. To give a little demo, I'll run this script. And essentially, the dev tools is looks like this. So you can give yourself money. So if you go to general, you can give yourself specific money, experience, stats, factions, and all of that. Just a word of warning. Using this is sort of like cheating in the game, but it's sort of like similar aspect as using cheats in Sims or Skyrim. It's really up to you. You're not really affecting anyone else but yourself. So if you abuse this dev tools, you're going to, I guess, ruin the experience of your game if you use it too much. But if you want to bypass things like, I'm just waiting for money, or I'm just waiting for maybe like for this thing to finish, then you can use things like time skip, for example, to skip for an hour or a day to simulate that, and then you're gonna get the money or experience for that, or even if you want to get tons of research points because you're just waiting to grind out the research points, you can then click on this tons of research, and then you're gonna unlock massive amounts of research. Yeah, so that's what it is. The code is pretty simple, but the theory behind it is kind of it goes beyond the documentation of the game. So what I'm gonna do is I'm gonna open up the my browser just to show you guys what I guess the context of this the dev tools is. Alright, so here we are in the web version of Bitburner. So historically, Bitburner used to be a web application that you can access via your browser through a GitHub IO link. And you can still do that today by going to daniellixie.github.io/bitburner. And you can this web version basically supports the same thing as your Steam application, but the only difference is that you can't sync it via a Steam Cloud, which is one of the updates in the recent releases. One advantage of, I guess, accessing the game via the web application is the fact that you have access to a thing called an inspector window. And you can do that by right-clicking on the browser and then hitting inspect. And all browsers support this functionality. They just call it different things like DevTools or something, but most of the time they have all of these things for you. And in this inspector window, they provide you with tools that allows you to inspect things about your website or execute scripts via your website. So the DevTools exploit actually involves understanding two different concepts. So the first is understanding the framework that Bitburner is built in, and then the second is understanding how to use a thing called a query selector in JavaScript. To answer the first question, what framework is Bitburner built in? Basically, Bitburner is built with React, and then to deploy it via Steam app, they use Electron so that it's a desktop application, but internally it's just a React app. And in React, there's three different concepts that's very important. So there's states, props, and components. Um, so components, you can see it as a function that displays stuff. So everything that you see here, so this element here, so this container here, this drawer here, this text here, all of those are components in React. And every single component takes in a bunch of data, so it takes in arguments. And these arguments to the components are called props. So props are data being used by the components to render information. So this value here, the money, hack, or all the levels, these are props. So they're either stored inside a player prop or even passed in individually. So HP, money, as like a primitive type, like a number or a string. And then the last thing is state. So state is basically data that's being used from within your application. Basically, Bitburner is implemented using a component library called MUI. And if you're using MUI, every single element that you use, so box, drawers, lists, all of that gets compiled into a whole bunch of divs, and then is tagged with some sort of class name. So, for example, this one, the div with the movie box root, basically tells me this is using a box element from movie, or paper, this is using a paper element. And the reason why they tag that with some sort of class name is for styling purposes. Movie is just, a standard component library to make everything look the same. And the reason why everything has classes is so that they can apply the same styling for every box element, for example. So yeah, that's the first concept. And the second concept is how to use query selector. And if you're not familiar with query selectors or JavaScript in general, basically query selectors allows you to query your DOM, which is your web page, for specific elements. So things like if I want all the divs, for example, I can use a query selector to select all the divs. If I want all the classes with movie box root, I can select all the classes with that attribute movie box root. And the DevTool exploit actually involves, I guess, a vulnerability where props are stored in every single in some of the elements of a thing called movie box root. And in one of the elements, they actually store information about the player, the router, and then the terminal window. And if we go to the console tab here, basically what we're gonna do is we're gonna try to build that query from the ground up so that you understand the process that went into creating the script. So first thing is typing in document. You can view document as just a keyword in JavaScript that symbolizes your entire web application. And then this document has a function called query selector all. So this means that I'm selecting all the elements with the identifier that I specify in. What we're interested in are basically all the nodes, so all the elements with the attribute movie box root. And if we I guess press enter and then hover our mouse above any of these elements, you would see that it tells you exactly where these elements are. And then if we expand this, you would see that every single element has information about the has stores information about React Fiber, which is probably just information about the actual element itself. And then and then also it's props, so it has all the children and all that stuff. So we just want to filter that out. So the first thing we want to do is we want to convert this node list into an array. So we can do that by going array from, and then this guy here. There we go. And I'm gonna assign this to a variable because it does get really big. So boxes, array from boxes. So if we print that out, it's basically just the same as this, but the only difference is that it's an array. And then what we want to do next is we want to convert I guess every single element into a bunch of entries that has information about the React Fiber and React props. So we can do that by going boxes.map, so converting that from one type to the other, and then box, and then object.entries box, like so. And what that one will do is that it's gonna basically, if it finds a key value pair, it's gonna turn that into an array. So if we look at the element here, you would see that one of the first element is React Fiber, which has information about the element, and then the second element is the React props. We don't really care about the React Fiber, so what we're gonna do is we're gonna extend this query here to only extract this the second part of the array. So we can do that by going boxes.map and then 1, so selecting the second entry. And then if we expand that again, you would see that I guess we extracted just the React props with the value associated with that. Basically, the props are stored inside this children.props property. So again, we're gonna extend this thing here, this small line here, to return the second element. For each of those elements, we want to return the second element, and then grab the children.props value. So let's copy this again, and then second element of children.props. There we go. And if we expand this again, you would see that some of the elements has information about whether it's a container or even like area stuff. But what's important here is this, so terminal or player. So you would see here that the player has information about your current player, as well as uh, functions that allows you to interact with the game. So if you want the player to apply for jobs, or change the bit nodes, or change the charisma, you have access to that. You also have access to the router. So if we open this window, you would see that you can navigate to any pages. So if you want to go to Bitverse, you can do that. If you want to go to the gang, you can do that. And then you also have access to the terminal window, where you can change the directories. You can put up command history, or put up actions and all that stuff, which is pretty cool. So we just want to extract the first element that has these arguments. So we're gonna assign this initial query into its own variable, just so that it's a lot neater to work with. There we go. So props, and then if we print that out, it should have the same thing. Yep. And then we want to find the first element with the player attribute there. So if we do that, so we got an error there, because what this find does is that it iterates through every single element of the array until it finds what it needs to. But if you go undefined and then dot player, then it's gonna throw an error. So what we could do to fix that is just putting a question mark before the element, and this is a conditional operator. Let's assign that to something else. Now we have access to do a whole bunch of stuff with that. So let's try out the router, and then we're gonna navigate to, I guess, achievements, and then you would see that this exploit actually controls stuff from within the game. So you can go to let's give that last command a go again, and then let's go to the Bitverse at level 1, and there you go. So you can see that we basically have control over what happens in the game. And then in one of the windows, there's actually a route called to dev menu. And then if we go to dev menu, you would see that we basically opened the page for the dev stuff here. So yeah, so that's the exploit. You can also modify stuff like the player money. So if you want to give your player, I don't know, 1E6 or something, $1 million or lots of zeros. You can do that here, which is which is kind of hacky, but feel free to use it however you wish. But again, a word of warning. If you abuse it, it's gonna ruin the experience of the game, so don't use it too much. So now that you see how, I guess how how all of this works, let's jump back into our game to cover, I guess, the entire script. Alright, so here we are back into the Bitburner client. So I opened the DevTools script just to show you guys what it has. And as you can see, it's very, very small. Basically, as I showed you guys, the first thing we do is we grab all the elements with the attribute MUI box root. And then from those elements, we then extract the props for each of those. And then after extracting all the props from each of the HTML elements, you would see that we then try to find the element with the player in it, because we know that that object has all the player, the terminal, and then the router inside it. And then we then navigate to the dev menu. If we look down here, you would see that the RAM cost is 26.6 gigabytes. And the reason for this is because they tried to prevent players from accessing the dev menu earlier in the game by giving this document keyword a massive amount of RAM cost. But there's actually a workaround to this. There's a keyword in JavaScript called eval that allows you to evaluate strings into JavaScript objects. And if we use the eval keyword to the document, you would see that the RAM cost went from 26 gigabytes to 1.6 gigabytes, so the base cost of the script. And then you can use that the same way as you would. So if we run this, you would see that we can still access the window. So it's still still not it still didn't stop us from accessing that. All right, so that's about it. I know I sort of went into a tangent by presenting this into instead of corporations, but in future videos I'm going to be showing you guys how to fully automate the division creation process of your corporation, as well as the management of that corporation. So stay tuned for that. But the reason why I presented this is because I actually recommended Bitburner to my friends, and then they actually got put off by the whole waiting and then the grinding aspect of it. It would be nice if if I could suggest anything to the developers. It would be nice if they could implement some sort of time skip filter or time skip feature that allows players to skip time if they want to. And the focus of the game should have been the whole problem solving and then the puzzle aspect. And if you imagine waiting an entire week to play this game and then discovering that you don't have enough money or you don't have enough research points to do the stuff that you wanted to do, then it's slowly gonna put you off over time. So by accessing the dev tools, it's gonna allow you to be more engaged, and you don't have to wait for too long to actually do stuff. But anyway, that's enough about that. Let's jump into the YouTube comments. Alright, so it looks like we have a lot of new YouTube comments, which is really good. So the first one is from Scott Elliott, and he says, whenever I try to connect to CSEC through food and stuff, it still says cannot connect directly. This error only gets thrown if you misread your analyzed network logs incorrectly. But if you go to my GitHub page and then download the stable build, there should be a script called find server. If you copy and paste that into your game and then run that and pass in the csec as an argument, it should print out a chain of connect commands that allows you to connect to csec directly from your home folder. Next one is from Reality Backhand, and he says, try to run the stable version of your codes, but it seemed to crash the game whenever run launch fleets. The problem is fixed when I revert back to episode 8 version, but it won't run pirates on purchase servers until I buy all 5 exe open port programs. I see. So I think that problem is already fixed in the latest stable version, and the reason why this doesn't work is because your purchase servers actually requires you to have all 5 open ports. meaning that you have to modify the get ships function to add your purchase servers manually if they have enough RAM. So if you go to my GitHub page and then go to the stable build and then open up launch fleets and then go to get ships function, you should have a piece of code where that has statements on what you need to apply to actually add the purchase servers manually. Next one is Aiden Skelton, and he says, I'm having a problem with Diamond Hand script because it will not earn money. It just keeps me broke. It takes all my money and then put it into the stock market and never turns a profit, and then seems to keep me at $2 to $3 million. Whenever my money hits that amount, it'll take it and just never profit on it. So Diamond Hands at its current state is very, very risky. So all it does is that it buys stocks if you have enough money, and then sells it when you have the opportunity. And then this opportunity is completely random, mainly because you don't have Diamond Hands doesn't support market manipulation at the moment. But to fix your problem, there should be a variable called risk threshold somewhere in the code. Make sure that you increase that if you don't want the Diamond Hand script to take all your money. And then that should fix that issue for now. Or you can just wait until I get to Bitnode 8, and then I'm going to be extending the Diamond Hand script to support market manipulation so that you have more control over what it does in the stock market. Next one is from Botsy Collins, and he says, when I start launch fleets via launch fleets JS and or autostarter, after purchasing formulas.exe, my Chrome stops responding. Either other scripts work. This only happens after I install augmentation. Before this, the launch fleets ran for hours just fine. Any advice? So launch fleets actually has a weird side effect where it actually freezes your game next time you reload it. And I feel like that's the reason why your game I guess freezes, is because launch fleets actually spin up a whole heap of active scripts which runs on workers, and then basically if you have a lot of workers, it's gonna have to kill that, and it's just gonna lag everything. But what I usually do is I usually just kill all the active scripts and then rerun launch fleets, and that generally fixes everything for me. And then next one is from Solus, and it says, might be a good idea to put the GitHub link in each video description since so many ask for it. Yes, that's actually a good suggestion, so I'm gonna be doing that on this video starting from now. Thank you for that. Next one is from Aries CRX, and he says, can we get a script to automate commit crimes? Also having a Google Doc in the description. So there is a GitHub page for this, so you can download the GitHub page, and then you can see all the scripts that I'm using. For the auto commit crimes, I'm gonna be doing that as soon as I access Bitnode number 5, I think, the singularity one. So just stay tuned for that one. Next one is from Dragon Army, and it says, I need help. Every time I run autodeploy.js, the game gets frozen because of an infinite loop, but I can't find it. This one's a bit of a tough one because that one's running on your game, so I can't really debug what's happening in your game. But one thing I like to do is I comment out a whole bunch of functions just to isolate where the problem is, and then you know, identify where it crashes line by line. And then as soon as I find that, then that's what I focus on. So yeah, so that's about it. So that's all the YouTube comments. So in the next video, I'm gonna be showing you guys how to create a script that would automate the whole hiring process for your corporation. So I'll see you guys in the next one.